We are looking to enhance the bit by bit project from the YByte Python curriculum available at www.ybyte.in. Previously, we have seen how we can give a different color to the LEDs. Remember, my class project worked with, let's say, red colored LED. Here I have yellow. I can pretty much use any color. In fact, that's quite simple, but we use bitwise operators to do this. Basically, we formed a 24-bit color, and then converted that to color string. So here I'm using yellow because red and green, but you can imagine literally any color is possible because so many possibilities exist. As any value can be given to, let's say, R, G, and P. Now we are going to go a little bit further in this. Let's say I want to give every LED a different color. So for example, I start with maybe yellow, but then by the time I come here, the color is something else, right? So each LED having a different color. In fact, we have all the tools available for us to use bitwise operators for this purpose. But before doing that, let's just briefly look at the structure of our code. Remember, we run a nested loop. There's an outer loop, which is run by this variable called count, where we are forming the pattern, right? So we go, let's say count 0, 1, 2 until let's say 1000 or whatever, a large number, but basically we form the pattern. But then there is this inner loop which runs with the variable kk, kk being the counting variable, but this is the one that actually depicts the pattern on the LED matrix that I have. And we run this using the tracer 0, which is basically like saying that, look, this happens without screen refresh. So, immediately the LEDs are displayed. So even though in this dynamic pattern, basically what's happening, the pattern is forming here, is being updated outside the loop. But in one, let's say, let's say in one screen, we depict all the LEDs together. So the point is that, if I want to give every LED a different color, I will have to modify this loop. In fact, I'll have to just put a little bit of control in this loop so that the color becomes a function of this kk, because kk is basically the LED index. And that's what I'm going to do here, right? And clearly we can use some other methods, but here we'll see how we can use bitwise operators for this, because it's also quite interesting. Recall, the main idea is that my RGB color representation allows me to represent this entire color as a 24-bit value. So if I can make these values a function of kk, then I can effectively get, let's say, different colors for different LEDs, and we can get some fairly interesting patterns, as we'll see in just a moment. So I get back here to my code. I've defined a color style called 1. And basically in this color style, what I mean is that I'll start with this color, which means the rightmost LED will always get this color. However, for the other LEDs, the color will depend on the index kk. And let's see how we can do that. So I come in here. Notice this is the inner loop where I'm, basically generating the LED pattern. So I just go and say, look, you know what? I want the color to be a function of the LED index. However, the starting color should always be whatever I've specified from the beginning. So I just put a small condition here. If kk is equal to, say, 0, I'm going to say, well, look, color, say color num, say kk, just define a new variable, is the same as CLR num. If not, if not, let's say else, which means for the subsequent LEDs over here, I'm going to say, for example, just one of the examples, I'm going to say, look, color, num kk, basically color num for that particular LED. For example, I could do circular shift left. Remember, circular shift is going to maintain the same number of bits, but it's going to take this in a kind of like circular fashion, right? The shifting happens in a circular fashion. And what will I shift? Well, I'll take the previous color, so color num kk, shift by, let's say, for example, 8 bits, and we'll see this in a moment. And thereafter, I just go and say, look, I'm shifting by left. This whole thing is a 24-bit number. That's why I put n bits to be 24. But remember, it's not the color number that I'm interested in. I mean, I'm interested in that, but I must convert this to a color string. Now, for that purpose, I can use a statement that I was using earlier. So I'll just go and pick up this statement from here, converting the number to the string, since we already have this. So I'll just go and, put this exactly here, right? So basically, before forming the LED itself, I just compute the color string kk. I basically take the color num kk and convert that to color string kk. So color num kk and color string kk. And given that I'm doing this per LED, I'm going to make this to, let's say, color strkk, right? Now, what that also means is that if I were to look at, say, different color styles, just to be sort of consistent with the code, I'm going to just ask myself, look, if color style is equal to, let's say, 0, well, then in that case, I can just CLR num kk is the same as CLR num. So that means that, for every LED is the same color that we had specified from earlier. If that is not the case, basically if let's say I have say color style is 1, then I can just go and do something like this. But in either case, I'll have to convert this to say a string KK, right? So now having done this, let's look at some examples, some nice, really cool examples. I'm going to start with some pretty interesting experiments here. So let's say I start with all blues, so I start with, let's say, 1 1 1 1 1 1 1 1, and there I go and do, for example, 0 0 0 0 0 0 0 0, right? So basically, I'm going to start with the rightmost LED being blue, but thereafter, say I shift this by 8 times every time the KK changes, right? So basically, if I, let's say, like I said, if I use a shift of 8, which is what I've done, what do I expect, right? I expect the blue to become green, to become red. Once it shifts again, it will become blue, and so on and so forth. So I expect blue, green, red, blue, green, red, blue, green. Now, in order to get a better visualization of, let's say, this entire process, I'm putting a print statement over here where I'm printing the color number in binary format, 24 bits. That's why using an F string here to do a 24B, 24 bits of binary. And I'm putting a 0B in front so that it becomes a little bit more easy to understand. So notice I'm starting with blue color and I'm shifting left by 8 in a circular fashion, right? So when I now run this as expected, blue, red, so blue, green, red, blue, green, red, blue, green, and then again it comes to blue, right? Remember, this is all. Now I can see this very clearly from here. For example, notice blue, green, red, and that pattern repeats. That's why it's blue, green, red, and so on and so forth. Now let's do something interesting. Let's say I say, look, I'll make the last one to be cyan by making green and blue both to be, let's say, ones. However, I will do some experiments. I'll do a left shift here by, let's say, different numbers. Remember, the rightmost guy will still be cyan, but we can, play with this. Let's say I start with a value of 1. We'll see how the pattern changes. In fact, very interesting this exercise is. So when I, let's say, run this, you notice it looks all cyan, but there's a tinge of green coming in, because basically it's becoming more and more green and kind of very visible here on the last LED. It looks pretty much green because blue is almost out, right? There's a little bit of a tinge of red here, but red is not getting maximized because the last bit is still not being touched, right? Let's say I made this, say, shift by 2. Another example here, so when I do this now, when I run this now, you notice the shift is that much more very visibly seen here. We started with, for example, blues and green, and then slowly it becomes red. So the last one is orange. So, lots of experiments are possible here because of the circular shift. We are getting all these colors without needing to know their exact names, without needing to know their RGB codes. But these patterns are really visible to us, and, it's fun. And, it's kind of mimicking more and more closely as to what happens in the real world in the, let's say, festival lights, right? Let's take one more example before we wrap this up. Let's say I say, well, shift by 4, right? So, see what happens. Close this. So again, I start with cyan, but clearly transition very fast into yellow, then to purple, and then back into, I guess, cyan. So again, we can see the number here and we see what's going on, right? So when I do a 4, sometimes it'll repeat, right? But you can clearly see this is interesting. Again, I have no idea what the names of these colors are. I have no idea what their RGB codes are. But I know that the RGB codes are being formed with this bitwise operators, right? So that's why this is interesting. Now, obviously, the possibilities here are, just for the sake of illustration, let's say I do a quick experiment instead of shifting. So what I have done is to set my color, initial color, to red. You notice I made R color to all, let's say, once. This time round I can, for example, do a color shift to the right side, RIGHT, and this I will shift by, let's say, maybe say 4 numbers. So red will go towards green and towards then blue, and everything else remains exactly the same. So when I now run this, you notice I start with red, go towards green, then go towards blue, and so on. And you can see that's very clearly on the pattern. It's kind of visible here. So very interesting how we are using bitwise operators to achieve all these effects, right? And obviously we have, this is just now, obviously, there are other things we can do. For example, we can, instead of using shift left or shift right in a circular fashion, we could do an and an or. So we can, for example, start with, let's say, all blues, take it towards white, for example, right? So really infinite number of possibilities exist. It depends on what is it that we want, right? I hope you found this interesting. Very interesting how bitwise operators are helping us here. Um, in general, building activities, applying concepts makes concepts that much more alive and that much more fun to learn. That is how we learn Python at YByte. Look at our website www.ybyte.in because we learn Python programming through such fun activities. Take care. Thank you so much. Bye bye.